All right, hey everybody. I missed this last week. Thanks for Simon for jumping in. That was helpful. All right, so I'm kind of jumping back in on where we left off last week. We were looking at an issue with Vulkan. Let me share my screen. I was working on an issue with Vulkan that we were having with our new Vulkan backend. And I think we fixed one of the issues, and we put up a draft pull request. Tomas was able to take a look at it, and it did partially fix the issue, but there's a secondary issue that we need to address. So let's jump into that. All right, so people are still coming in, but they'll catch up quickly. Not going to wait around. All right. So this was the draft PR we put up yesterday, or last week, or 2 weeks ago, sorry. So Tomas came back with fixes the hard-coded swap chain, which that was the main goal, and fixes the glitch on, depending on the first present mode fix, but maybe not. Okay. So there are new flickers that were not present before. Let me make this bigger for people. There are new flickers that are not present before. It kind of looks like the same flickers that were there when the descriptor cache misses, or maybe still. Yeah. So, and we were seeing something like that in the sample. Full screen VSync mode switches are acting weird. They both trigger black screen for a few seconds. And exclusive full screen doesn't respect the requested resolution anymore. That's particularly interesting. That suggests a timing thing, potentially, that that the state that's being passed is used, or the timing of when it went to full screen changed, or we're overwriting something by doing it the way we did. I guess we'll have to take a look at that. But I want to start first with the flickers, because we definitely saw that case. It'll probably be best for us to try to fix that since we can reproduce it. So let's go back to our Vulkan sample here. I'm just going to run it first. So all right, here's our sample, and this works fine, and this is working fine. Yep, so all this was working okay. All right, so yeah, okay, I just want to loop around and play all the levels so that I can be certain that nothing's going wrong here. Right, so that was working okay. I think it's after resize. Was it resize? No, it's not just resize. It was something special about that. What was it? I remember it flickering with the ends, this end message flickering. Oh, I know what it was. We were forcing it to do that, like pretending like the swap chain did change, so it would force it to rebuild, which is a case that would happen, when it did change, or in some platforms it might take this path. Well, yeah, I know it changed. Let's see. I'll just start over. I don't know why I didn't like changing it on the fly. So we basically did this, and when we resize, it'll regenerate everything. And that time worked okay. We got a bad issue that one time. Why was that? Oh, there it is. So we'd run into this. And then we get bad state here, which yeah. So you can see it's still there. It's that, and this is what he was talking about, where new flickers are not present before kind of looks the same flickers that were there when the descriptor cache had misses. Where was that issue? Might give us some hints. Probably wouldn't hurt to. Let's see if we can find the issue that was related to that. Okay, let's go take a look at that real quick. No, we have increased retention if you use 3 frames, 2 is not working. Okay. It's been a while since it's funny, I wrote the original descriptor cache code here, but it's been a long time since I looked at it, so I need to refresh myself with it. And this is probably not a bad way to do that. Interesting. Pre-fill free descriptor sets now. Let's see. We hash the frame index with each frame. The swap chain has its own uniform buffers. They expand the descriptor set. If we don't, some frame will use the wrong buffer if the descriptor is retrieved from the cache. So it suggests that maybe we need to, well, I mean, I think we already do clear the uniforms in here. Yeah, the uniforms are destroyed and recreated. But I guess the descriptor cache has not been, right? I mean, first of all, does it make sense to nullify the descriptors and recreate them? You know, does that make sense? And can we do it? Which I'm not sure if we can. We have to go take a look, or at least I don't remember if we can. So resets, resets. I hate that I use the word sets in here. Sets is such a generic term, but it's the descriptor cache essentially. Okay, that's why I called it a set. What frame it was created and the set itself. So what happens? Let's go look and see where these things are created. Again, it's been a long time since I've messed with this, so I have to kind of refresh my memory while I'm at it. What? Am I not finding it? There it is. So and my first thought is I wonder if we could basically salt the cache for the descriptors so that if we have to recreate the frame buffer or the swap chain, that instead of hitting the same cache again and finding the same cache result, it is forced to create a new one, invalidating the old ones and letting them go away. Just in a natural way, the same way it normally would be. I wonder if that's I wonder if that's a good solution for this. That's a good thought. I'll keep that in mind as we move on here, because that could actually be useful. Actually, I haven't been paying attention to our comments here. Let me turn that music a little further. People complained last time about that stuff. Let's see. Comments. Where are our comments? There's chat. Hello, everybody. All right. If anybody has any thoughts or suggestions, leave them in the comments. All right. And if you're not, we're trying to get our Twitch subscriptions up to meet some, I don't know, milestone on Twitch so we can unlock some features. So if you haven't followed us on Twitch, do that. If you're watching on YouTube, make sure you subscribe to us on YouTube. All right, so now that that's done, let's get back to this. So yeah, maybe salting the cache value so it forces a new one would be an interesting way to make it recreate the descriptors. And I think that's what we really want to do, is recreate the descriptors, because I mean, I guess I don't know if there's anything in the descriptors that is tied to the inner details of the swap chain. I mean, even if it wasn't, oh, why is that saying that? That's interesting. I changed that. Annoying. Bang. Much better. Working on Vulkan bugs. Already had it ready. It was just doing the wrong thing. All right. Back to thanks, Simon, pointing that out. Back to chat. Let's see. A question from one of the foundation guys. Can you give a brief overview of how Vulkan differs from OpenGL? Yeah, I guess I can. How Vulkan differs from OpenGL? I mean, Vulkan and DX12 are. I mean, the intent behind Vulkan and DX12 was to get rid of some of the things in the driver level of these APIs that made some games slow. So, when you look at OpenGL and DX11, there's a lot of code in the driver that is trying to optimize for a general case. And in some cases, they would make optimizations very specific to games because it needed to understand the patterns of how memory was used. Well, in designing Vulkan and designing DX12, they changed the APIs so that you have a lot more low-level control over memory allocation and how memory is used and reused. And that's the core, the core difference here is how you manage memory for your, during your render. And with that, with certain engines and certain rendering in certain engines, you can potentially really optimize what you're doing because you know exactly how you plan to use these things. Whereas with the old APIs, the driver really didn't know how you plan to use it. It wasn't told ahead of time, this is how you plan to do this. So it has to just take a guess in the general case. And sometimes that wasn't a good, good optimization for a particular game. So with the new APIs, you have very low level control. So the descriptors are basically defining everything that it needs to draw some triangles to the screen. It's kind of like everything pulled together of everything required for this particular draw for it to work. It's what shaders are bound, what uniforms are bound, what textures are assigned, the samplers, like all the render state. It's all in the descriptor. So as you're rendering, it's on the fly building these descriptor caches that are building these descriptors that define how this set of triangles is going to go through the pipeline and render, or this draw is going to go through the pipeline and render. And this is what under the hood, this descriptor caching is what under the hood the drivers in DX11 were doing. They were trying to gather all the state, bind it together, and say this is how this is going to work. And then it under the hood would, again, every time you submit a draw and change all the state, it would try to figure out how to best assemble these and make these caches. With DX12 and Vulkan, not only can you control that, so you can control how these things are created, you can also technically serialize them and reuse them in later. So people will serialize their pipeline in order to have pipeline state that's already ready so that you can just render without having to build any of these things. That's not how MonoGame is set up in our usage, because we're still underneath a traditional DX9, DX11 style API. So none of this stuff is exposed to people at the C# level, but it is something that that we plan to eventually expose more of, specifically memory allocation and memory usage, or how memory is used, as well as, and those core things kind of help with the next big feature, which is being able to render in a thread. Not really render, but build a command buffer in a separate thread so that you can get some parallel work done. And that's part of the feature API stuff. Let's see. Hello, Ars. He's listening as he's driving. Yeah, I do that a lot too. It's almost as good as a podcast. So, getting back to this. So yeah, I wonder if I could potentially lazily recreate these things instead of forcing them all to be generated at the beginning. Let's see. Process caches. Let's see. Begins the frame. So at the beginning of the frame, we go to process caches. So this kind of is cleanup work. It is kind of slow because it goes through all shaders. We should definitely do some optimization there, but that's not for now. Moves them to the free cache set. Okay, so let's go back to finding where use sets are created and set up so we can understand that again. Update descriptors. Gets the current frame shader. Dynamic offset. Dynamic offset is for things like, I believe that's for like the vertex buffer offsets. All this is very much coded specifically to how MonoGame uses it. Apply bindings to the new descriptor set. Uniform offset buffer. Can we see very well? Let me get my text bigger here. I should have done that earlier. Sorry about that. All right. So here's the checks dirty. The uniform slots change. The samplers. That's interesting. Wonder why it does that twice. Is that a bug, or is that the only one that exists? I guess we kind of consider both of them at the same time, so it's one flag for both. And I guess the idea was that, probably is fine. Usually if you're changing, you might change it at the same time, and if you're going to do this work anyways, it probably is not a big deal, but it's kind of weird that it does it twice here. Let's see. Or actually, no, that's not true. That's the flag comparing to this. I guess it has to do that. Yeah. Still kind of weird. All right. So it checks to see if the descriptors have changed for this, and if so, then it generates a new one. I mean, here's where I could introduce something to kind of force the change potentially. For sure, the hash of the new state. So it hashes our new state for uniforms and texture slots. I hate when we do that. Don't do that. White space is free. It makes things easier to read. Goes back and looks through the use sets to see if we already have one. And that hash is based on the... Yeah, so this is where the frame index hashing ended up happening, which is, I wonder if possibly this is... So when we're rendering here, I think this is still running. We're seeing one frame with it correct and one frame with it wrong. It means that the frame with it that's wrong is finding a hash because it exists. Why is it not breaking in there? It's annoying. Let's go double check why that is happening. So we should be getting this thing breaking here. Could be that it's not copied that the Vulkan binary. Yeah, it's probably what it didn't do. Let's see. Nope, it's working now. Okay, good. Guess I must have changed something. Okay. It's also interesting that it works fine until it gets to this screen and it breaks, but only for one frame. So it should be always getting a, yeah, so it never finds one missing. It puts it into a free. So I bet that if I force it to free all the descriptors, that it should fix things. So let's just try that, because it's a simple thing to try. If it works, it works. Then we can decide whether we need to optimize further. So we'll start there. That seems like the best place to start. So so put some into the free sets. Do we ever free the free sets is the question. Pre-fill the free descriptor sets now. It's based on a very specific pool size. I think how it grabs these is it grabs the first one off the top. So if that's the case, yeah, it grabs the first one off the front and pops it. I hate kind of like this. This is so cumbersome. The STL people really wrote a real weird thing, but pulls the first one off the front and pops it so that it. So if I push the old ones onto the back, then chances are the ones, at least for now, chances are the ones on the front won't be reused. You know, and since it's building them 1024 at a time, there should be fine. So I could probably do a simple test here of just moving all the use sets into free and then letting it reuse them. I think that might be the best way to do that. Let's see, do we ever do that on our own? We do hit here. Or what? We take the. No, it actually destroys it. Is that a leak there? That's a good question. That looks like a leak. I mean, I don't think we ever really destroy shaders on a regular basis, but we'll see. No, I'm kind of going in depth here, but I want to really understand things as best as I can before I go any further. Okay. Let's see, a question from Simon. Can you explain at a high level how if Vulkan aligns with DX12 since they're on the both in the next release? I mean, they're equivalent essentially. You know, there's minor differences in how the APIs work, but they're equivalent. You know, they both run on the same hardware. They have the same basic goals. You know, of providing more raw access to memory allocation and control over the pipeline versus the older APIs. But they're essentially equivalent. The reason that we have both is because DX12, you know, aligns with certain platforms that we want to support, like Xbox as well as Windows, and it's a good API on Windows. Vulkan basically fits everywhere else, but also fits on Windows. So they both kind of complement each other. It'd be nice if there's one API that just worked everywhere and was consistent. There just isn't. So you have to support multiples. So we're just keeping with, you know, what we've done in the past. In the past, we've had OpenGL and DX11. Now we have DX12 and Vulkan. So same sort of thing, you know, but we plan to push, you know, eventually the DX11 and the OpenGL backend will probably start being phased out as Vulkan gets stronger and DX12 as both those two get good, we're going to stop using the older APIs and eventually we'll remove them. But for now, they're going to be in there. All right, so this might actually be these just look suspect. Probably doing this because at the time we're like, well, is it safe to actually delete these things at this time? And no one ever did it, but like, we need to investigate that. Let's see. So we're not quite doing this. So yeah, I can just do a really lazy thing here. Let's try this. Let's do something really, really hacky here, just as a test. So when it does this, I have no clue whether this is going to work or not. Let's see. We're going to do this. Device. And current frame, we're just going to do 0. That'll make sure that all the caches are released, I believe, or put into the free list and force it to recreate them. So let's see what happens. Sometimes the best way to try something is just to do it, not overthink it. What did it not like? Not found. Oh, damn it. It's that old thing again. It's not declared ahead of time and it's in the wrong order. Just stick it way up here for now. Won't be a bad thing for it to be up here anyways. We have some other pre-declared functions up here somewhere. Yep, there we go. So it won't hurt to do that. Don't like how that looks. Put it there. All right, that should do it. Not implemented. Yep, not implemented. All right. Verify things are still working here. Resize. It's going to come here, and it's going to go through all the shaders, and it should free everything. Because you set 0, free sets 1024. You set 0, free sets 1024. There's just 2 shaders at the moment. Look at that. So by freeing all the descriptors and forcing it to recreate it, the flicker goes away because it recreates them correctly for the updated frame. I think, at least. I could be totally wrong. Is this a great approach? Not sure. I can probably do it in a safer way than what I'm doing right now. In theory, it should be. In theory, it actually is pretty safe because if we're getting rid of the swap chain, like the swap chain is being regenerated, then the swap chain is being regenerated, then all rendering has to have already stopped. So those descriptors are not in flight anymore. Because normally the descriptors are currently being used because the GPU is always rendering in the rear, right? So it's when you say, hey, draw something, you might be telling it, you might be building the next frame while it's still drawing the previous frame. So in this case, when we're recreating the swap chain, like it should have already been done rendering at that point. We can't recreate the swap chain because, and if it was still rendering to it, so at that point everything stopped. So in theory, not in theory, in practice, that means that this is a good solution because we're forcing all the descriptors to be put back onto the free list. And then it will reuse them later. And when it goes to render the frame, it says, oh, I need to recreate these descriptors. I mean, is it super efficient? Possibly not, but it 100% gets rid of the flickers because it rebuilds it, fixing any bad state. And it'd be nice to know what that bad state was, what it actually was, but I don't know if it really matters at this point. If this works, it works. It'd be interesting to see if I wish I had some better test cases than this. But let's experiment with a couple things. I think for now we can claim victory on this because I think this is actually a pretty decent solution. It's elegant, it's simple. Yeah, it takes some extra work to do, but if you're recreating the swap chain, like you're already doing extra work. Recreating the swap chain is not free. It takes some time. I don't get any black screens or any delay. It just does it. I need to fix this to go to full screen, I think, because Tomas had mentioned a full screen case that was a problem. But with this recreating the swap chain every time, I'm not getting any problems here. It looks like it's working well. Yep, this is not a bad solution, I think. Pretty simple. I love one-line fixes. Now, will this solve Tomas's issue on other platforms? Do not know for sure. Assuming that the issues all stem from, the swap chain being recreated, and in theory it should, because all the descriptors will be recreated and we're good. And yeah, recreating all the descriptors is an expense, but you already incurred the expense of. I don't think anybody expects full frame, full speed rendering, high performance while you're resizing the window, or changing, the GPU display or anything like that. Actually, let me try something real quick. I don't think it does this anymore. Yeah, I just moved this to my other windows. I have three desktop windows. So moving to the other windows to see if it does anything different. It shouldn't. It's all the same GPU, but it shouldn't do anything different. All right. So this is good. I think this is actually a good fix. I think I might actually want to commit this fix. But let's add some documentation here. Should it be inside of here? Yeah, it doesn't have to be inside of there. In fact, I don't want it inside of there because that only happens if there's old frames. Should just always do it. Do it as part of deletion, right? Like you usually want to delete things before you allocate new things. That usually works out better. This is just that array. Ignore that. It's just this array. It was temporary. Wait, where does that array get allocated? Yeah, there. Just this temporary array. Use this for building that. It's a different thing. But usually better to free things first, even though it's really not freeing anything. It's just pushing back into the cache. Since let's see. Since we know that all rendering has stopped, it is safe to free all the descriptors and let them recreate on the next draw. removes all flicker. I hate when my text does not line up properly. It's a weird thing I have. It's a weird thing I have that I don't like the text to be lined up weird. I don't want to think about how much time I've wasted on stuff like this. Probably too much. All right, so gives a little context of why we're doing this and that it's safe. So yeah, this is not a bad solution, I think. In most cases, this won't even happen. It'll only happen if for whatever reason, your swap chain count changes, which means that you change graphic devices, or you have a weird laptop that changes graphics devices when you take it off the battery, or when you fold or unfold or expand or whatever, or some Linux devices, I guess, can do some weird things as well, or Mac. So that will only happen in this. I need to make sure I put this back once I get done testing. Right now, I'm just using this as a test. So let's commit this real quick here. Push this fix. Let's see. We can put that up there. Oh, I had some stuff I haven't pushed. There was a couple things I hadn't pushed. Little white space fix there. All right, so force. So, forcing the swap chain to be force recreation descriptors when the swap chain is created. That's better. I hate the same word in there twice. I'm going to push this so that it's an RPR. Make sure that I have problems with that. Let's see. Man, too many windows. There we go. Right. So I think that could address this. I wish Tomas was around. He could maybe verify that for me, but I think it does. So here's a question real quick. What kind of performances can we expect from the first VK release? Better or worse out of the box? I mean, really, I think you're going to expect. We're hoping you have none. It's not going to be better. It's not going to be worse. It could be slightly worse, but I don't expect it to be better. The reason why is, Vulkan and DX12 are not fundamentally just faster if you're using them the same way you use DX11 or OpenGL. I mean, I got this information a long time ago from a Microsoft engineer that worked on the DirectX team. Like, they were doing experiments where they would replace an API. They would replace a DX11 renderer with a DX12 renderer under the hood of some API for some project, and they could never get good performance out of it. Like, the performance would be at best equal, sometimes a little worse, but it was never better. And it was because fundamentally those APIs don't add performance unless you use the API the way it was designed. If you don't take advantage of what it allows you to do, build pipelines ahead of time, cache them. If it doesn't, you don't, manage your memory at the low level like it's designed to do. If you don't, use these features, then it can't really help you. So in our case, we're really not taking advantage of these features, mostly because how the rendering works in an XNA like API is very much, what we need that to work that way. And for it to work that way, there's really not much we can take advantage of at this moment. That said, there are some things that could be done if we wanted to get more performance out of it. If we felt like we really needed more performance, we could do. For instance, we could expose more of the high level API to the low level. For example, sprite batch. In theory, we could expose an API from sprite batch to the native code and write a lot of the sprite batch internals in native code using and optimizing memory usage, and specifically so that we could take advantage of these APIs and what they can do for performance in those cases. But I just don't think that that's really worth it. I've yet to see. Most games are not bound. Most MonoGame titles are not bound by sprite batch performance unless you have a bunch of other contributing factors. I don't think that just sprite batch performance is the biggest bottleneck. That said, you could have a special case that requires it, so it's possible. And what we want to do moving forward is expose more of the features that can allow you to take advantage of that stuff. Sometime back, we worked on a project that had some performance issues. And we were trying to figure out how to get some more performance out of it using just stock MonoGame, even though we could modify it, just using that. The trick that someone had mentioned to us, which is pretty genius, was sprite batch. You can kind of use it as a threaded renderer. You could allocate two different sprite batch objects, in a deferred mode, and from two different threads build your batch. You don't want to execute the batch; you just want to build it. And by doing that, that means that you had two threads working in parallel, building your geometry basically for your sprite batch. And then once those are built, the main thread could then come in and say, okay, once these are built, now just call sprite batch end on each of these two in the right order. And it basically was a command list, essentially, which is pretty genius. But that totally works. And something like that doesn't require anything at the low level. You're just basically splitting out the work of building geometry into, a dynamic vertex buffer into two different threads, and all the checking to see if a cache changed or if I need to break the batch or do anything just gets moved off to those other threads. So we thought was a pretty genius approach to doing that. It only works in very certain cases. It can't actually do a draw in the middle of that. It has to actually batch it all together and only draw on end. But we thought it was a pretty cool technique that I haven't seen before, so that was pretty neat. This is some years back. So yeah, I don't expect that you're going to see suddenly, your performance is 2x better or something like that. It will. I think we'll be happy if the performance is the same as, if Vulkan and DX12 have the same performance as DX11 or OpenGL. I think we'll be fairly happy with that result. Moving forward, though, we plan to try to expose more of these APIs so that you can take advantage of them and get more performance out of MonoGame in general. Let's see. Do we have another question here? Let's see. I guess it's a response. Yeah. Makes sense for VK specifically. As I understand, most performance games would be expected on the CPU side rather than GPU side. Yeah, exactly. It's all managing CPU side performance. I mean, it could be that the new way that you can build and cache pipelines can maybe allow the pipeline to be, if you're going to cache a pipeline, you can optimize it a little bit better potentially, I guess. So there might be some minor, GPU side wins, but mostly it's all about CPU side and managing that. I mean, that's really the big slowdown in DX11 and OpenGL is all the work the driver does, on that within it to optimize things. Let's see. So what else? I guess that's the last. Oh. Another question. One more question, then we'll keep going. Will shaders be able to take advantage of the more modern shader language options with Vulkan and DX12? Would be the low-hanging fruit devs could use. At the moment, no. We're just aiming for compatibility with what we've done in the past. And right now, the shader story here on MonoGame is kind of a mess. There's slightly different versions of HLSL that you use, depending on what platform you're targeting, and some differences you have to have in your code and everything. as we move forward, the plan, after we get Vulkan and DX12 out there in this preview release, and we get 385 out, which is what our big push is right now. Once we have that out there, the next step is going to be, as we get those refined and everything, I want to dive into the shader, the whole shader pipeline, and rework that from a couple different angles. One, just simplifying everything. Like, there's a lot of dumb things that are in there that are kind of legacy, that are no longer important, that we can simplify and make it easier. So we kind of want to have a subset of HLSL that that we know works across all the platforms. You build your shader once and it works everywhere without you having to do a ton of extra work. That's the idea, is to get to that point. Now, is that going to be 100% for everything? Maybe, maybe not. There could be some minor things you have to deal with, because we definitely see it when we port to different consoles. We'll find things where it's like, this console, shader compiler does not like this specific, construct, and we have to rewrite how the statement is in order to make it, compile correctly. So there'll still be some minor things like that, but I want to get rid of the bigger things, like how your samplers and textures are defined, this shader model definition, which is just annoying and unnecessary in a modern age, how the uniforms are defined. We want to clean all that stuff up. Also, speaking of uniforms, MonoGame's never really supported multiple constant buffers internally. Like, MonoGame exposes everything the same way XNA did, which is in effect, and effects have parameters. But there's never a concept of parameters having multiple groups, at least at the XNA API level. You could define them at the shader level, but I think that when it was an original XNA with shader model 3 and 4, I don't believe you could even do multiple constant buffers at that time. Probably not with shader model 3, but probably you could with shader model 4. But the point is that we don't do anything like that. Everything that we compile basically shoves everything into one constant buffer that gets updated, which is not very efficient, because every time you change, you might have a constant buffer that has, 30, 40 elements in it, and you're changing one of them for every draw, but it still has to upload the whole constant buffer every time. So it's not efficient. So taking advantage of the fact that you can build multiple constant buffers in your shader, and then having the MonoGame internals take advantage of that and only update a small constant buffer instead of one giant one. It keeps one big one that stays static and the other one changes. You'll get some really good performance optimization. So there's a lot of things like that we want to unlock that are going to require some reworking of the shader pipeline here. But yeah, that's coming up next. So for right now, nothing really different in the shaders. Are there some things you could take advantage of? Maybe, but it's not like something that we're touting as a feature. It just is, if you're able to do that, congrats. Let's see. Yes, building the sprite batch geometry and threads is a great story. Yeah, it is. It's kind of, when someone mentioned to me, it's like, wow, I didn't think that you could do that, and that was pretty genius. Let's see. I think GL needs shader model 3. I thought VK would bump it to 6. Is that actually true? I mean, it does require that, yes. So it requires shader model 3 for GL, and VK would bump it to 6. Yes, that's accurate. But so there are things that you could take advantage of. That said, it's again per platform, depending on what target you're hitting and things like that. And we want to avoid doing that in the future. We kind of want to make it so you can build your shader and you can feel fairly assured that it's going to work on all the platforms. Within limitations, obviously. They're always going to be like, well, I really have a shader that I need to use on mobile that, performs well there and is optimized for mobile. And I have a shader that performs well on higher end systems. So there'll always be that, but I just don't like that, you have to like really change how all your samplers are defined if you're going through the old school, way of defining samplers versus the more modern way of defining a sampler, for example. Like, we want to kind of get rid of that. And that'll be part of this change. So let's see, that'll be enough questions for right now, but we'll get back to this stuff. Hang on a second. Let's get through this first. So I think that this flicker thing might be, he didn't really elaborate too much on, kind of looks like the same flickers that were there when the descriptor cache had misses, or maybe is still. That's the original issue, I think. Yeah. No, it's a different issue. Is that new? God damn it. I hate it when it just doesn't tell me the date. It makes me do math. All right. So interesting. So, okay, maybe that is, I don't know. We'll have to see. Tomas is going to have to test this to be sure. Full screen and VSync mode switches are acting weird. So I can probably test that. Will trigger black screen for a few seconds exclusive. Full screen doesn't respect the requested resolution anymore. I'm not sure if anything that I did could affect this, but I need to double check that. I mean, we did move where some stuff is allocated or defined, so that could be that. The VSync mode switch is acting weird. I can test that case because I can definitely hook that up to the code and hook it up to a key to switch VSync mode and see if I can trigger any problems. And I can test it at full screen. So I'm going to test these two cases and see what happens there. Make sure my commit got in here. Should look that for one to see if my commit got in here. Yep, so that's there. All right, let's do that real quick. Let's fix this to, this would be the easiest way to do this, wherever the main window is for this platform game. So we had allowed resizing. We're going to basically hook it up to a key to allow us to do full screen. Yeah, let's do that. Load content, update. Okay, we're going to put it in here. Let's see. I think I did this once before in here. So we have the keyboard state here. Okay, let's do this. If do we keep the last keyboard state? I hate APIs that don't. Ugh, this is really gross. This sample sucks with that. It like you really need to detect a, a press. You really need to know, was it down now and was up the previous frame? So you really need to keep a keyboard state like that. I hate when doing stuff like this because it means that you have to like very carefully hit a button to make sure it doesn't get screwed up. But I'll live with that for now. Who cares? So we'll just have to live with this. And we're not going to do escape. Let's just do V. Then we can do. How do I get to the graphics device from here? I guess I can. Well, no, that's the graphics device itself. I want to get to. Oh, this already is game. Okay, duh. What's the right way to set this? I think you have to set it on the presentation parameters, don't we? No. Where is it? It's on. Yeah, what's the right way to do this? I'm blanking. Oh, just graphics. That's where I want to do it. do toggle synchronize vertical retrace. And I think after doing this, we have to call changes. I think we have to do that. Let's see what happens. In theory, when I do this, we should see frame rate change. Of course, we're not printing a frame rate, so that doesn't help. It definitely didn't like that. Interesting. Buffer destroy. Recreate swap chain. Okay. So yeah, that caused the swap chain to recreate. It also triggered a bug. So that's interesting. Null buffer. Interesting. Oh. Must have done it fast enough that the buffer was not. I must have done it fast. I must have hit it. Like, this is the case where I hit the button for a second, but it, like 2 frames in a row, it did it. It probably didn't render the next frame, so it was already null. But I mean, that's something that, you know, we can. I guess this was already here. It's a question of like, should this allow us to pass in a null buffer and it be okay? Seems like at least somebody, you know, I possibly wrote this code. I can probably find out who wrote this code. That's something where you sometimes have to come up with a standard, you know, whether you want these things to be forgiving or not, right? Like, you want this function to be forgiving and say, if you pass a null buffer, then ignore it. Or do you want to say, wait a second, something might be wrong. You've got a null buffer here. In this case, there was nothing wrong here. It was valid for it to be null. And I'm gonna stick with what's there. So I'm gonna assume that it probably should be the caller's responsibility. So we'll make it the caller's responsibility. That will keep that from happening. What was happening there is, as I was hitting it, it was it got 2 frames in a row. It hit that. It ended up. So there's the flickers, which if I'm holding it, it's going to flicker because it's like constantly swapping it back and forth. So it's doing crazy stuff. Let's get something on the screen so we can actually tell what's happening here. I don't need you. Yeah, let's get something on the screen. Where is it rendering that text? Was it rendering level? Oh, there's time. Okay, so I'm going to take advantage of this code here for draw HUD. Let's go draw score. In here, I'm just hacking this because I just need something that works. I'm going to draw basic. What's it doing with that? Time height vectors here. Oh, it's measuring the height of the time string and working its way down, whatever. I usually prefer not to do it that way, but you know, whatever. I'm going to hack it however I like here. We're going to do let's take advantage of more modern language stuff. I'll do that, and the location will be. What was it using for that? I was just pushing it in from title safe area. I always find that syntax very plus new. I just hate that. It's very odd syntax. It feels weird. I'm just going to do 30. Sounds like a good number. And Let's make it red. Fun. So that should render. Oh, 30 sounded like a great number, but I was wrong. If I'd done the math, it would have been fine. But no need for math. Let's just hack something in there. Okay, so we see VSync. Hit V, you can see it. It is toggling. You can see how, like, because we're not checking down versus up state, you know, it can sometimes, I can hit, it hits multiple frames. The frame rate is high enough, especially when it's the VSync is off. It's worse. But here we're able to toggle VSync, and we don't see any problems. But you know, this explains the situation, right? Like if I went back to the old code here, where this would no, it was free, wasn't it? That's gonna be the name of the function we put in there. Yeah, if I disable this, see, and this normally wouldn't be called, but I guess this is being called for some reason on some of his platforms. Who knows why exactly? It could be that when the VSync changes, it could trigger a different result for that. So here, I think if I do this, we should get bad results because it's the same thing as resizing the screen. So if you see, so hitting VSync. Oh, notice that was interesting. I scaled the window, hit VSync, and it changed the window down in size. So this might be part of what he was saying there. This is why testing this stuff is important. You know, he was saying that they both trigger black screen for an exclusive full screen doesn't respect the requested resolution anymore. I suspect something here, right? Like hitting the VSync toggle, it lost the window size. Why did it do that? You know, that shouldn't have changed that. It suggests that this resize does not. I guess it's because the presentation parameters didn't change in this case. Maybe. I don't know. It's interesting. I'll have to look into that a little bit, but it shows us something. So cool. That gives us something to go with here. Put this back. Let's see. 30 viewers. Kind of stalled out at 30 viewers. We need to get more viewers. All right, so I think this will still do that same effect here. When I VSync, it restores that. I need to do a couple things here first. I need a cheap FPS just to verify. I just want to see that we can, while we say the vertical retrace has changed, I want to actually see something. So let's see if I can get a cheap FPS. Seems like a good number. Do we have anything for that? Who cares? We don't need to bother with that. Let's just do a yeah, simple enough. So let's do I guess I want to check the time versus the last time. Yeah, try to think of a nice and simple frame rate counter here. Let's just use the elapsed time. Not the best, but it's something. Actually, in there, that won't actually work, right? Because it's fixed. We need to do it on the draw because it's not really the update. So I need to track something. So let's just do what's the best way to do this? I don't know, I'm blanking right now. Sure, let's do. Not even accumulate anything. I'm just gonna keep that. Probably not accurate at all, but that's fine. Actually, this is probably fine, actually, because it's in the draw, right? Yeah. Since the last call to update. That's probably not a good thing, huh? No. Probably not great. I need to figure out how to make that stop doing that, huh? Yeah, I don't want to do that. I guess stopwatch is simple. Let's just stopwatch. Be done with it. Start it there. We'll go draw to draw. Let's do it for HUD. Yeah, it'll be fine. It'll be fine. I don't need to do anything fancy. I just want to see a change. It doesn't matter if it's accurate. We'll just put the milliseconds. And I think that's extremely simple. And we'll just do it as a long, because then it's just going to give me raw milliseconds. That tells me a lot. I mean, frame rate is sometimes deceptive. Milliseconds is not. So you can see there, it's fairly locked, a little flicker. So I'm going to toggle this. Now, oh, you know why? Because, wait, why? That's interesting. I wonder why that is. Is that because... Oh, is it because we're set to... It's the game... What is it? It's... It's because it's set to... It's not for fixed time step, is it? I don't think that's... Can I get... Yeah, fixed time step. That's what I need to do. No fixed time step. That might cause other kinds of havoc, but we'll see what happens. Yeah. Yeah, now we're 0 milliseconds per frame because it's And the timing is all screwed up. Like it won't even let me. There it goes. Yeah, the game doesn't like these, the game was designed around a fixed frame rate. The game code was. It was not simulated any other way. Like, I die if I turn off disable VSync. That's funny. These old samples are written in kind of weird ways. You can see, like, milliseconds per frame goes to 0. I can probably do something better than that. Let's try this. That will give us. I'm not using var. That'll give us at least a floating point set of milliseconds. So we're getting a fraction of a millisecond now with VSync off. Anyways, wanted to just get an idea of that. So, okay. So we know that VSync toggle causes at least one problem. It does not resize VSync toggle doesn't break anything with this change. So that's good. But it probably, I guess the question is, why is it breaking on the resize? So let's take a look at that real quick, because we can. All right, so if we go in here and what I want to see here. I see the problem. It didn't really resize anything here. What's the actual difference here? Oh, swap chain is null. Oh, that's right, because the caller freed the swap chain specifically so that it would force a recreation. So that's why. Okay, duh. I was reading it backwards. So interesting. Even though we're resizing the window, it's actually not resizing the swap chain. It's just, which is interesting. Why did it? Okay, no, there's a change. So it actually had to change that time. Huh? Why didn't it do that last time? Okay. So I have an actual swap chain size change, which that's coming from. Let's see. Out of date. Interesting. Oh, so that's the only reason why it happened? This is suspicious. I don't know if I like that. Not sure if that's the right way for that to guess it's always 0. I'm surprised that that's not changing that. I mean, I guess it is the swap chain, I guess. It's not 2 back buffers. So yeah, I guess that makes sense. I guess that makes sense. Let's see. Some Visual Studio question. Is that tabs window on the far left plugin for Visual Studio some option I can enable somewhere? It is an option you can enable somewhere. I experimented with it a little bit. I used to always work the other way with the tabs on the top. This way, the traditional way. But I was having problems. I just didn't like some of the results I was getting with it. No, I do not have time for a call. So I experimented with the changing it to this, and it's been okay. It's a little bit better sometimes, but it doesn't. It feels like it doesn't do what I want it to do. Like you would think that the code that you most recently worked with would be at the top, and it's not. It's at the bottom. It looks like. So if I come in here and change level, no, it's not. Oh, wait a second. It's like recently opened. Yeah, what I wanted to do is kind of organize the tabs by recently used, right? Like the most recent ones I used at the top. It doesn't have that, So I just don't like my options here. It's like recently used what I want, because a lot of times, the tabbing sort of does what you want, which is if you tab once, it goes to the previous one you were on. So it's recently used is the order that it does that, When you alt tab, it goes to the first thing that was used recent. Active files, it's like it's recently used. I'd like this result here. It would shift around and stuff, but I think that would be better. So I'm just doing this with alphabetic before and see how that works for me for searching stuff. I end up with a million tabs a lot of times, and I'm just experimenting with trying something different. I've been using Visual Studio since Visual Studio 2, literally Visual Studio 2 from the late 90s. So I've been using it for a very long time, and I've kind of settled into a pattern, and I wanted to try and change that up. So let's see. Okay, so back to what I was doing. So yeah, I didn't expect this to happen. It's interesting. I wonder, resizing the window, I guess it's because we're not doing it in our code. It's kind of falling back because it's just doing it via, Vulkan itself is saying hey, something's wrong. You need to recreate the swap chain. This will occur if the window is minimized. I guess Vulkan is detecting that the window is associated to is out of date and automatically forces this recreation, which I guess could be the reason why Tomas is seeing stuff on changing the size of a window. I guess it didn't. I expected that to be handled on our code side, but I guess it's not in this case. Not that I don't think that matters though. So yeah, what I wanted to see here. So we have a different size there. So these are our sizes. Let's hang on to that. A lot of times I'll use the window snipping tool. It's a way to hang on to something. So hang on to the. It's not going to stay there. So I'm going to hang on to you, and then I'm going to toggle the vsync. See what happens. So when I toggle vsync, it's back to 4440. So that's where it's happening. So why? Where's this width and height coming from? It's coming from here. So yeah, the issue is, and this is really, I guess, more of how this code is written than anything else. The resize is coming from. Question is, where is the resize size coming from? Because here it's coming from the presentation parameters. And it's saying, oh no, it should be this size. So when we resize the other way, where's that coming from? Let's see. originally comes from this. So now it has a different size. So somebody changed this size along this path here. Who changed this? Is the question. Is that like a... So, hey, I'm going to test something real quick here. Well, that might break something. Let's see. Yeah, let's not do it yet. Make sure it doesn't use this for boot out. It does use it there. I'll do it at the very end here. I'm going to go in and then hack this. I'm going to change this to 830. And then I'm going to let this go. I'm going to scale this higher. I got 830 back. So it's a feedback loop. It's getting its previously defined size instead of coming in with the size. So it's like whatever my size is, that's the size it's going to be. But I think that's all because of my code. Like I don't know if this should actually be. I think this is doing as we defined it, which is, you know, no one's resizing the presentation parameters. Like this isn't changing. Because of that, that's why that window, and the fact that it resizes the window to the back buffer size is kind of interesting. I don't know if that's a Vulkan thing or not. Yeah, I'm not sure if I know enough about how this is structured to say what it should be doing here. Definitely got to do that. Well, the VSync is definitely fixed, I think. You know, as far as VSync toggle should not create bad descriptors, that's for sure. Will it work for Tomas's case, which is on I think it's on a Linux box or a Mac box, I'm not sure. Exclusive full screen does not respect the requested resolution anymore. That's one that's a little hard to test because I suspect, I mean, I don't know if testing exclusive full screen, you know, would break my stream here. It's curious. Let's try and see what happens. What's the worst it could do? Explode. If my stream goes down, I'm sorry. Probably shouldn't, but I just know that when you go to exclusive full screen, you can do some crazy stuff. So I want to do here. How do you do that? Hardware mode switch. We set that. And that'll make sure that it does that. And I think that we need to support Alt Enter for full screen. Pretty sure that's what we have to do, fortunately. Again, we're going to run into the same problem with, yeah, let's just fix that. I just hate that I have to, the sample is written badly. So where's our keyboard? Wait, oh well, but we only keep one. Oh, you know what? Duh. That's all I had to do. That will keep it from doing that. I hate having it. It's so dumb that we have to write this every time. The number of times I've written helpers for avoiding doing this, it's kind of ridiculous. I think we have to do this, right? I don't think there's a built-in Alt-Enter. I always forget if there's a built-in Alt-Enter. Yeah, there's not a built-in Alt-Enter. Alt-Enter on Windows generally takes you full screen, especially with games. So I'm just going to do graphics. And since I think that'll actually I think that'll do it. And since it's already set to hardware mode, let's do false hardware mode for right now. Let's see what happens first. See if it actually does what it's supposed to do. And then we'll try hardware mode. Okay, did it. Am I locked up? No. Oh, it's not toggling because I didn't set it to toggle. Let's fix that. Easy swap there. Okay, so we have a toggle. You know, it verifies that toggling does not break the descriptors with hardware mode off. I'm sure it would have with hardware mode or without my fix in there, the recreation of the descriptors. So that for certain would have done it. So now let's try with hardware mode, and that's where things could get weird. Let's see what it does. I'm going to put this in my other window so that if it does blow up, it's in my other window. It's going to modify my desktop resolution, but it did it. Hopefully, the stream is still alive. I'm interested in what it did to the stream. Oh, interesting. So it worked. That's good. Oh. Okay. Interesting watching it change the stream. Oh, column errors. Interesting. But hey, it seems to be working. Shits and giggles. Let's take a look if we disable the fix. Let's see what happens if we disable the fix we put in here. Where is it? So here. Disable this. My guess is that things will not work very well at all. Let's see what happens here. So everything's fine here. And then I'm going to Alt-Enter. Yeah, instantly flicker. And I bet you it'll even flicker after I end this level because the descriptors are screwed up, which makes sense. I wonder if the descriptors will be good if I go back to this. It's already screwed up permanently at that point. So I could see how maybe he ran into problems without this change, but I think that that's all we need to make it work. Huh, that time seemed to work okay. Interesting. I wonder why sometimes it wasn't happening. I wonder if it's because I had enough bad state created that the cache now has the the cache ends up, well, no, there was a case that was bad. Okay, so we know that it wasn't working in another case. So that's good. Wrong window. This window back. All right, let's put this guy back. So this looks like a good fix. I'm happy with this. It seems to might have fixed the other issues. So let's see. So that built. I think I had another change in here. Did I not? I think I did. Where's my window? No. There we go. I had another change in here. What was this? Okay. Oh, was this if max image count is that max image count case? Yeah, it was something I noticed. I went and looked at the API and it was like, wait, there's a max image count. So we need to also make sure that we don't generate more than max, even though, we want to define it as at least 2. I guess it's, I would assume min image count will never be greater than max. It's coming from the API, but if it does, at least we're protected against that. And I assume there'll never be any piece of hardware that wants more than 2, that requires, only 1 maximum. But, you never know. But this is more correct. Oh, we had this fix. That. We'll ignore that for right now. My local hack. Let's test without my local hack just in case. But really, I think the only case is if it falls into here is when it would actually break. So let's just make sure though. So we'll run that, verify. So that you died, I think, is because of the I got rid of the fixed frame rate. It does weird things when it gets a long frame now. Thinks it ran out of time or something. Full screen. Okay, still get good. It's full screen, but it's still rendering 800 by, or is it 800 by 480? Yeah, because we don't change the presentation parameters to be full screen resolution. This is that fixed resolution. Okay, cool. So my fix should protect against these flicker cases. And it was just a one-line change and a couple little cleanups. Less code than even we did last time. Let's see. All right. So, did I test resizing the window? I think I did. Yeah. All right. So that's good. Let's see. Did I push everything? I think I did. Always hiding windows. No, I didn't. Let's push. Let's write Tomas a message. All right, let's see if he will get to it eventually, but hopefully that will fix the last of these issues so that we can actually ship Vulcan as part of 385. But we're talking to the rest of the foundation members. They really want to try to get 385 out, and if we have to, we can maybe hold back Vulcan in this release, or hold back making an official preview release of that. But I really would like to get that out here, because that was going to help a lot, I think, moving things forward. All right. I think this is all a side effect of that. So this, yeah. So I think that one simple change was enough. Could it be more efficient? Maybe, but I don't think it's important for this case. Let's see. Was there anything else in here that was a problem for Vulcan that we need to look at? Let's take a look at those validation layer complaints real quick. Was complaining about a few validation layers that are not related to any known issues that might cause compatibility issues with some drivers. Validation error. We got another 20 minutes here, 22 minutes. We'll see what I can figure out here. Not that my streams have to be 2 hours, but command buffer complete semi 4. Interesting. Let me name. I think I have the stuff with validation layers on here. I don't have the Vulkan SDK installed, I think. I can do that real quick. I don't know if I have to have. I don't know if I have to match it with our Vulkan or not. Let's for right now assume no. See if we can. If that's all we need to. Sure. thick core. Just do all. Oh, it's a lot of them. I don't need to cross compile anything. Sure. Oh, install bars. I have pretty fast internet. I'm surprised that's that slow. Wait, did the music just get faster and slower? That's weird. Let's see. So after this, should, I don't know if I need to do that or not. Sure. Okay, that looks fine. So I should get Vulkan validation layers now, I think. Yep, enabled on. Already got some stuff. Is it the same two things over and over again? Submit, but may still be in use. Yeah, it's the same thing. So I'm getting the same validation errors that he was seeing, so that's good. But yeah, I swear it's using the I wonder if that's the semaphore it's talking about, though. I don't think it is. Maybe it is. It gets it out of the command buffer, which is the one that's tied to a particular frame. I'm pretty sure that we're creating a semaphore per complete semaphore. I don't know which one it's talking about, though. Will still be in use by Vulkans. Render complete semaphore is being signaled by VKQ, but it may still be in use by swap chain. Is there somehow that it's getting them? That looks correct, right? Like it's getting this specific command buffer, then creating these semaphores specific to this command buffer structure, which is tied to this particular frame. Unless this command buffer is the same one on both frames, which would be dumb. Let's see. So it creates a command buffer. So let's see how this guy's assigned. Okay, somewhere we're creating on these guys. Let's find where we're creating this guy. I'm tired of this round. Pass it. It's weird. It's like it just always existed. I guess it always does exist. It's just a member of this thing, so no one actually allocates one of these guys. So it's part of this frame, so there's no way for it to be a different object. Let's set object name. So signal semaphore is 0. We're going to complete semaphore 0. Wait, what? Most recently acquired image indexes 1 0 1 0 0 1. Like why 2 zeros in a row? What's that up? That's weird. Why would that be the case? I mean, that would be why things are weird, potentially. I have to research this being odd because we're getting double zeros of 1, double zeros of 1. It's really strange. It sort of suggests that something is up with that. Well, I don't think I'm going to sell that today, so I think that'll have to be the end of this. So yeah, all right. Well, I think we have some progress here. I wish I would have gotten that done last week. It's been a busy couple of weeks for me, so it's been hard. But I do plan to do more of these discussions. I'm going to assign myself to this Vulkan validation layer issue. I'll have to look into it next. Just because I want to get this thing done. Any response from Tomas? No, he's probably busy. If he can verify that this fixed the flickers for him and he's getting good results. I'm not sure about exclusive full screen doesn't respect the requested resolution anymore. That might be a completely unrelated issue potentially. are going to have to do with when I move that code from the startup to, you know, the code for setting up the swap chains from startup to or the count of swap chains from the startup into the actual swap change resize. Maybe it was passing in a fixed resolution at the beginning that it was keeping or something like that. So that should be easy to fix, but I don't see where I need a better example of this. Let's see. See if we can give me an example for next time. So yeah, for sure we'll do this again next Friday, either with this or something else. I really want to do a stream going over some Ascent stuff since we've been working on that. We have some more art and things, and it'd be probably good to show some of the work on that that's happening in the background. And yeah, any other questions? Let's see. No questions, at least none so far. So yeah, this was great. I'm glad we got this fixed, and I guess we'll see everybody next time. I'm supposed to show a message at the end. I was told I was supposed to show a message at the end when the stream was over. Get off my thing there. So yeah, next time, maybe we'll be some more Vulkan stuff. Maybe this stuff will get worked out this week. The PR is up on our GitHub, so you'll have to be able to see that. And maybe next week we'll go over some Ascent stuff if we don't have another stream like this sooner, just whenever time allows. All right. Thanks everybody. Goodbye.